Alright guys, what's up? Welcome to lesson 4.6 in the Intro to Python course. This lesson is going to be going over exception handling. Specifically, it'll go over what is exception handling, why would you use it, some common Python exceptions, the try and except blocks, catching some specific exceptions, the else block, the finally block, raising exceptions, some best practices, and finally some more practice problems for you guys to practice out your skills. So, what is exception handling? It is a way to handle errors that occur during the execution of a program. Without handling, such errors can cause a program to crash, which can cause a lot of issues in certain development situations. So, why would you use this? To prevent program crashes, handle unexpected scenarios, to improve user experience, provide more meaningful error messages, and also continue the control flow with an error. Say, for example, you're looping over someone giving you a number as an input. If they put a string into that, that's going to cause an error and the whole thing's going to break. Instead of doing that, you can just catch that error or check for it, and you can just tell them that they did the wrong thing and to do something better, then their whole experience improves. Debugging aid as well. You can identify errors a lot easier without stopping the program. So here's some common Python exceptions and errors. There's a value error, which is when a function receives the wrong type that is inputted to it. And here's an example. If you're trying to convert an integer out of just some random letters, you're going to get this error. Here, let me run it so I can show you guys. Okay, the next one, there we go. Value error. A type error is the next one, which is raised when an operation is performed on incompatible types. Like if you're trying to add a string with a number. There's a zero division error, which is raised whenever you divide by 0. Oops. There we go. There's a key error, which is raised when a dictionary key is not found. There you go. There's index error, which is raised when accessing, or I believe key error might be, no, that's an, never mind. Ignore what I was just saying. Index error is what I was thinking of, which is the next one, which is raised when accessing an invalid list index. So if the list has less elements than you're trying to access, you'll get this error. So now we get into the try and except blocks. The try block code contains code that could raise an exception, and the except block handles these errors if an error occurs. So here's the syntax of it, and here's an example with a value error. So say you're getting a number, like I said before, and converting it to an integer, and then printing out the number they entered. If, in this case, if the user enters not a number, say they enter like their name or something, then, or they enter like a string, it will print that it's not a number. So let me see. So if they enter in a number, everything will run fine. This code section won't be ran. If they get a value error like this, they'll get that's not a valid number, and it'll say that to them customly. If we didn't have this here, the whole thing would crash. Hold on, let me show you for example. And then this error gets there. And even furthermore, it doesn't matter that much on like a single execution thing like this. But if you wrap this inside of a well true block or something, hold on, let me have a break. If you wrap it inside of something like this, the user keeps entering numbers. If they need to enter data more than one times, or if they're able to, and they enter like this, it will continue the execution, and it will just tell them that that's not a valid number. Please enter a correct one. Oops. And then that'll give them like an actual error message in your program that will tell them what to correct and what they're doing wrong, instead of just kicking them out of it, and then they might lose progress, data might be lost, etc. So, like you saw here, I checked specifically for a value error. You can just do except like this, and they'll just do any error. If there's any error in the code, this block will run. If not, then everything will continue. But you should usually try to do a specific error. So here's the syntax for it. You can do specific errors here. Try something except exception 1, exception 2. And here's an example where you have a numerator you enter and a denominator, then you're dividing them. So you have to enter valid numbers first. If there's a value error, this will run. And if the denominator is 0, the 0 division error will run. So let me show you real quick. So you enter value 1s, it runs just fine. Or if you enter valid input, it runs just fine. If you enter a non-number, it'll tell you to. For either one of them. Because it's just whenever that error occurs, it'll run. And then finally, if you enter 0 here, you can't divide by 0. So there's another block to this. There's the else block. This runs if the try block succeeds. You usually don't need this. In very rare occasions, you might. But because you can usually just put this code inside of the try block as well. But it's here in the Python thing, and it's still worth like covering a little bit. So there is an example. If this happens, it doesn't run. So the finally block contains code that runs no matter what. If an exception is raised or not, this section will run. So here's an example of that, where you're trying to open a file, and if the file doesn't exist, then it will print file not found, and then it will print closing the program. Even if the try works as well, this will still run, and it will still print out closing program. So to raise exceptions, you can explicitly raise exceptions using the raise statement. So here's an example of that, where you can raise a value error, for example, to add custom errors into your program, and type in age cannot be negative. And you will show that message to the user. So this is really useful if you're building out libraries or things for other developers. This works really good if you're building out programs for users to use. This works really good if you're building out libraries and things for other developers or yourself to use. So here's some best practices. Like I said before, you should handle specific exceptions. So this isn't that good, where you just do a common thing, where you just catch all exceptions, print an error occurred. What you want to try to do is do specifically like a value error in this case, because then that will also tell you that if there's an error that you're not expecting, say you get like a divide by 0 error, this is just going to tell you an error occurred. Here you'll get the full error feedback, and it will crash, and you'll be able to see and debug a lot easier that. And you could also handle very specific things this way a lot better. So next, try to keep try blocks short. Keep them as short as possible. Only include code that might raise an exception. You can have multiple throughout a program. Use meaningful messages. Provide error messages that are good to help people, like saying invalid input instead of an error occurred. This could be even better. Invalid input. And then whatever their input is, blah, blah, blah. Or invalid input, ABC is not an integer. And just something more specific like that is very good. Avoid silent failures. Always print out or log whenever there's an error, instead of just ignoring them and trying to bypass them. So now we have some more practice problems for you guys to test out what you learned and kind of solidify the knowledge. Once you're done, post them in the community. If you get stuck, you can also post them. Pause the video here. I'm going to go through them. So first, handling user input. Write a program that asks the user to input 2 numbers, prints their division result, handles value error, and 0 division error. So this is like the example above a little bit. So I'm actually going to do a while true here. Option equals input quit question mark. If option equals y break else try print please enter two numbers to divide. Input, and I need to assign these to variables still, so I'll do that next. Oops, I accidentally ran it. I think I misspelled that, so I'm just gonna do denom. And then I need an exception for value error. Print at least one of your numbers was not an integer. And then accept 0 division error. Print cannot divide by 0. Except as e. Print you got an error. And I need to put this here. And what this does, I didn't cover this in the lesson, but if you do except as e, I'm pretty sure this is the syntax for it. I might be wrong, and I'll see once I run it, but this will put whatever the exception you get inside of this variable, and then you can print it out for like really good debugging information. And then let me do finally print program running again /n. And then here I need to cast these actually to integers so I can divide them, either integers or float. Let me do float actually, because I just feel like it. There we go. Except let me look up the actual syntax for this. Exception as e is what it is. There we go. There we go. Quit. No. Please enter two numbers to divide 5 and 4. Program running again. No, I don't want to quit. 5. No, I don't want to quit. 6 and 0. Hold on. I never actually divided them. And then I can do quit this real quick. Now the divided by 0 error should work. Never mind. Oh, I did minus. I'm dumb. Number 1. Number 2. I'm changing this just so the output looks a little better. Let me see. No, 5, 0. There we go. Cannot divide by 0. And then no, 5 and 7. There we go. And as you can see, you get very useful debugging information, and the user gets feedback instead of the program just crashing. All right, task 2, sorry. Custom error. Write a program that takes user input for a temperature in Celsius, raises a custom value error if the input temperature is less than absolute 0. So, print hello, please enter a Celsius temperature. And then if temp I need temp equals input integer input. Oops. And then there we go. I'm going to wrap this inside of a try block as well because there's an integer section there. Except, what is it? Is value error. Print not a number. And then if temp is less than negative 273.15, raise, then value error, brr, way too cold. And I actually want to make this a float because we're comparing it against a float here. Please enter a Celsius temperature of 5. Everything works fine. 5. It breaks. And then negative error. Brr, way too cold. Oops, I had an extra thing there. There you go. But anyways, that's how you do these problems. That's how you do try and accept and some error control in Python. Thank you guys for watching. I hope you guys learned stuff. Can't wait to see your guys' answers to these problems in the community. See you guys in the next lesson.